we're going to take a quick look at a few things from section 124. So just kind of point out, and then we're going to get to the reflection. So just kind of some interesting things here. Hopefully we would have noticed if I go 180 degrees clockwise, it actually ends up being the same thing as 180 degrees counterclockwise. So 180 degrees really doesn't matter the direction we're going. And then we can also see 90 degrees counterclockwise is going to be the same thing as 270 clockwise. So if you go 90 one way and 270 the opposite way, you actually end up right back at the same location. So really quickly, we're going to take a look at 182, and then we'll get to the reflection. I'm going to kind of jump ahead of the translation. So first thing is I'm going to plot 4-1. Again, we've got to make sure we are labeling. There's a lot of people, as I was walking around, was not labeling today. So we have those points right there, A and B, and I can connect them to be a line segment. So again, we could use our patty paper because it's centered at 0, 0. It allows us to just be able to turn our paper. So if I'm using my patty paper, I would just put my pencil at the 0, 0, and then I would turn it once. But again, I'm just going to go ahead and turn my paper. So 90 degrees counterclockwise. So I'm going to turn it once to the left, and we should have something that looks like this. So I'm going to write down what these points became. So our A prime is going to need to become -1, 4. And then B prime has turned into 1, 2, 3, 4, -5, +2. So that's what my new points need to be. So I'm going to turn it back around, and I'm going to plot those. So -1, 4 is going to be A prime. So again, we have to label, have to label. And then -5, 2 is going to be our B prime, and we can go ahead and connect. So that line is going to be the 90-degree rotation counterclockwise of the given line. And then it goes on to ask some questions about rigid transformations, but I think we addressed all of those in class. So I am going to skip ahead to 184. So if we look at that, it says copy AB and BC. It's already there for you. So I would need to draw in where A prime B is going to be. So if this is a reflection over this line, we can look and kind of see how far it is. So A prime is going to have to be somewhere over there. So I can draw that A prime, and then I can go ahead and connect those as it says there. So we would end up with something that looks like that. So when points A and A prime are connected, I went ahead and connected those. What figure is formed by A, B, and A prime? So A, B, and A prime would be those right there. And that is going to give us an isosceles triangle. The reason we know it's an isosceles triangle, again, that whole rigid transformation idea, if it's a reflection, AB has to be the same thing as A prime B. So we would know that that would be an isosceles triangle. This AB is the same thing as A prime B. And then the last thing, use what you know about reflection to make as many statements as you can about the shape from part A. For example, there are sides that must be the same length. Are there any angles that must be equal? So based off of that reflection, there's a few different things we can say. We already discussed it, but I could say segment BA is congruent to segment BA prime. If you want to put B prime, A prime, that's also fine. We could also say that angle A is going to be the same thing as angle A prime. So angle A is congruent to angle A prime, so that's a possibility. And we could technically name them, but if it's a reflection, this angle up here, angle ABC, would also have to be congruent to angle A prime BC. So that could work. We could even say these right here are going to be the same, so ACB would have to be congruent to A prime CB. Okay, so there's a bunch of different things that we could say there. We'll kind of just leave it as those two. So again, big ideas, rigid transformations, transformations that if the figure we start with, the figure we end with are congruent to each other.